Welcome back. Now we are all set to write the C program for evaluating a postfix string. In the last tutorial, I explained how this algorithm works with example. Now we are going to implement this algorithm using C programming language. I have already written the code that is required to implement the stack. We need a double stack, that means a stack of double elements. I have already declared this here. You can see that it's operand stack and it is having an array which is of type double. As the result of any mathematical operation, especially the division, is going to be a double value. That's why we are taking this array as double array. And we have this push, pop, and isEmpty method. These are the standard stack operations, and I have implemented all these here in this program. So they are as usual, and I think you are comfortable with these stack operations by now. Now we have this operate function. This is going to operate two operands depending upon the operator. It's going to receive three parameters there: the left operand, right operand, and the operator. If the operator is plus, it's going to add up the left and the right operand and return the result. Okay, so the name of the left operand is left opnd, so it should be left opnd, and here it should be right opnd. Okay, you can see that if the operator is taller, then it's going to perform a to the power b using the power function of standard math library. That is how it's working. It is using the switch case statement to perform the operation. Depending upon the OPR, it's performing addition, subtraction, division, or multiplication, or even a to the power b. If it is encountering any other operator, then under this default, you can see that we are just printing a message and just terminating the program. And ultimately, it's returning the result to the caller. Okay, the actual implementation of the postfix evaluation is going to take place here in this eval postfix function. You can see that it is receiving the base address to a character array, that is the postfix string. So the caller is going to pass the base address of the character array that contains the postfix string, and this function is supposed to evaluate the value of that postfix string and return that value to the caller. So the return type of this function is double. You can see that, and we are going to implement the actual logic here. The algorithm that we discussed last lecture is actually going to be implemented here. So we need a stack for this purpose, and that is the operand stack. So we are going to declare operand stack here. And we need to initialize this stack with -1. We need a loop counter. I is that loop counter. And we need to iterate through the postfix string until we encounter the null character at the end. So it's going to be postfix I not equals null. And each time within the loop, at the end of the loop, we need to increment I by 1. Here, I would like to mention one important thing before we proceed. I have considered that each element of postfix string is of one character. That means each operand is also of one character. That means we do not have any operand that is of multiple digits. If you are having operands with multiple digits, then you need to change the logic for extracting the tokens from the postfix string. As far as the evaluation of postfix string goes, that would remain same. And I will discuss about in details how to extract a postfix string having multiple digits for a number or operand in some later lecture. So for the time being, let us consider that each number in the postfix string is of one character. So we need to pick up each token from the postfix string, that is the next element of the character array. So just postfix I is the next element of the postfix string. Now we need to check whether this token is an operand or operator, and that's quite simple. If the token is greater than equals character 0 and token is less than equals character 9, then obviously it's an operand. The postfix array is a character array and each element is a character element. So the 0 or 1 or 2, whatever the number is there, it's a character, it's not a number. You see that we are comparing token with character 0 within single quote. That is the ASCII value of the character that will be used here for comparison. If 5 is there, it's not the digit or numeric 5, it's the character 5. That means ASCII value of 5 is there. If you're not sure about how the character is kept in memory, please go to the C programming course where I have discussed in details about how the character is represented in memory and how the ASCII value works. The character 0 is having ASCII value 48, character 1 is having ASCII value 49. In this way, character 9 is having ASCII value 57. So if you're having a character variable and initialized that with character 0, it's actually not 0, it's 48 there. So if the token is actually 5, then it's 53 there. And we need to convert it to integer 53 or numeric 53 before inserting it or pushing it into the stack. And that we can do just by a simple subtraction, token minus 0. Now, if the token is 5, that means it's 53 there, and the ASCII value of 0, if you are using 0 within single quotes, it's the ASCII value of 0 will be taken always. So, and that's 48. So 53 minus 48, it's going to be 5. So the character token is going to be converted to integer value. So the character token that contains character 5, so that's 53 minus single quote 0, that is 48. So 53 minus 48, that's integer 5. Now we need to push this into the stack. So we are calling the push operation, passing the stack address as the first parameter and the value there as the second parameter. Now the push receives the value as double. You can see that it is receiving double there, but this v is integer. So what you need to do is to convert it to double. A simple typecasting is going to be appropriate here. Okay, so if the token is an operand, we are just pushing it into the array. Now, otherwise, if it is an operator, that means if the token is either of these plus, minus, times, slash, or dollar, then what you need to do, we need to pop twice the stack, and we need to pop the stack twice, and we need to do the operation by calling the operate function, and then we need to push back the result again into the stack. So let me declare this opnd1, that's the right hand operand. So popping first will return me the right hand operand, then double opnd2, and I'm popping again, calling the pop operation. Now what we need to do is to perform the operation, just calling the operand function, and we will pass opnd2, that's the left hand operand, then opnd1, and then the operator, and that is token. Token contains the operator right now. So you can see that we are calling the operate function. It's operate. Okay, now the operate function is going to receive these operands and the operator, and it will perform the operation and will return back the result. What you need to do is to push back this result into the stack, and we are done. So I'd like to add another else here. So if it is neither an operand nor an operator, that means it's something else that's not recognizable by our program. So we should terminate it here. If something else is encountered, we are just terminating the program, giving a message there and terminating the program. So at the end, whatever is left in the stack is the result. So what we are doing, we are returning the value that is popped from the stack to the caller. So just popping the stack and returning that to the caller. So here is the main function that has a character array named postfix here. We are just asking the user to input the postfix expression, and we are scanning the postfix array, and then we are calling the eval postfix function and passing the base address to the postfix array. Obviously it's going to return the result, the value of that postfix string, and we need to just print the result there. Okay, we are all done. Now it's testing time. Some quick corrections. I have named the stack as operand stack, but here you see that it's stack only. It should be operand stack. And here also I made the mistake. Since I copied this from the previous program, they remained as a stack. And also here. Okay, that's it. Okay, let us now try to compile this program and execute this program. GCC postfix _ eval.c, that's our program. I have saved that in my Udemy folder, just using the GCC command to compile. It has compiled successfully, so we need to run that /a.out. So it is asking for the postfix expression. Just give a simple one, say 4, 5 plus. Yeah, that's 9. Now let's try with some bigger value, say 4, 5 plus 3, 6 minus times. 4, 5 plus is 9, 3 minus 6 is minus 3. So 9 times minus 3, that's going to be minus 27. Okay, it's working fine. So we have implemented the postfix evaluation logic using a C program. I hope that you have enjoyed this. In the next lecture, I'm going to discuss about the conversion routine. That means on given an infix string, how we can convert it to a postfix string. And we will develop the algorithm for that, and ultimately we will be implementing this as well using C programming language. And in that case also, you will require a stack. I hope by now you have understood clearly how stack is helping us to solve certain problems. Data structures are friendly, powerful instruments for the programmers, and we use them for solving our problems. The data is kept in data structure in such a way that it helps us to write the code and to achieve our goal. Thank you for watching.